Hi, and welcome to Basics in Cytobank. My name is Jeff Cracker, and I'm an application scientist at Cytobank. Cytobank is a machine learning-assisted analysis platform for single-cell data that analyzes, securely archives, and enables collaboration in the cloud. In case you're unfamiliar with Cytobank, there's several portions of our company. We have our cloud-based software, where we have high-dimensional analysis tools. These are things like Visney, Spade, and Citrus. I won't be talking about those today, but you can access videos on those on our YouTube channel, and we have webinars regularly that highlight aspects of these features. And we also have structured content management tools, and we'll be talking a little bit more about these today. These are things that help you organize, archive, and collaborate with your data. And then in addition to our software, we also have an informatics consulting group that does analysis for customers on a project basis. I won't be talking about them very much today, but keep in mind if you have questions, we're happy to answer them. Just send us an email by going to support.cytobank.org. One of the first questions I get when I talk about Cytobank is about the safety of storing your data on a cloud-based software. We take data security very seriously and work hard to make sure we have a secure repository for your data. Here are some steps we take, but if you'd like more detail, you can visit our white paper at this address down here. So today we'll be talking about the foundational kind of basics of Cytobank. Things like how to make histograms, contour plots, gating, how to annotate in Cytobank, which is very central to how the software works, tools like compensation. We won't be covering our advanced algorithms like Spade, Visney, and Citrus. But again, as I've referenced, we have summary videos of these on our YouTube website. We will, however, talk about some other features we have in addition to the basics. Things like sunburst plots, colored dot plots, heat maps, way to export aggregate statistics, and a quick summary of how our API works. All of these basic features are, like I mentioned, foundational to these machine learning pipelines that we recommend with our advanced algorithms. For example, here's one that involves doing the raw data processing in QC with these basic features, running Visney on the data, taking the Visney result and plugging it into Citrus, finding significant differences between your groups with Citrus, then visualizing that data back on Visney. And this is important to remember, all of our advanced algorithms require some kind of curation of the data, and we'll cover how to do that today. So first up, the inbox, the very beginning. How do you get your data into Cytobank, and how do you start working with it? When you first log into Cytobank, you're presented with a screen where you see all the experiments you have access to. If you have a brand new account, you'll see only experiments with a little globe next to them. This means that these are experiments visible to everybody on the server, and we've made several of our demo experiments visible like this for people to practice with. Today we're going to be using a PBMC experiment. It's flow data, and it's relatively simple. It's a handful of files that have been stimulated and some compensation controls. However, if you wanted to upload your own data, you could use this green New Experiment button. From here, you have the option to give your experiment a name, give your experiment a purpose, and ideally a couple sentences about where the samples came from, what the intention was, how you processed them. But we're just going to use some text right now. And then you click this green button. You're then presented with a screen where you can drag and drop your FCS files if you have the window open right next to you, or if you need to go looking for them, you can use this little green button here to browse your computer for your files. Once you drag them here, there'll be a list. When you click upload, they'll upload 2, 3, 4, 5 at a time, and then it'll bring you to your new experiment. Again, we're not going to take the opportunity to do that here in the interest of time, but that is how you upload your own data. The other way to get data in Cytobank is to make a copy of an existing experiment. To do that, we're going to look for an experiment in question using this search box. Here I can type in PBMC and find back that PBMC experiment again. However, you can also find experiments by filtering your inbox by different categories, experiments that I own, my experiments, experiments shared with me, public experiments, everything except for the public experiments. There's a lot of ways to go about doing this. You can also search for experiments based on sample tags or based on top channels. So there's a couple ways to find experiments in your inbox. In this case, we're going to be using this one that my colleague Angela has uploaded. So when I click on this experiment, we're brought into the experiment summary page. And we can see here, this is Angela's experiment, so we can't do that much with it. But we'll come up here to the actions bar in this shortcut bar, and from here we'll make a clone of it. So to do that, you click on clone, And then you can see you have lots of options on what you want to take with you into your new experiment. So from here, I'm going to take just the FCS files. I'm not going to take any of the gates, the sample tags, the compensations, or anything that would make for a very brief demo. So in this case, again, we're just taking our experimental files and all of our compensation controls. So I don't want to take any project membership or sharing access. Again, just the raw data, and I'll keep the experiment name the same. So from here, mark it as a clone and say submit. And then we'll get our own copy of this experiment in our inbox, and we can go from there into the rest of our analysis, like gating, annotation, and perhaps algorithms. Before we do that, though, we're going to hop into the experiment summary page. It's a great way to see everything contained inside of an experiment, and a good way to make sure that you can see any attachments that are there and any saved figures. So to check out the experiment summary, you go up to Actions and say View Summary. This is now my copy of Angela's experiment. So you can see the experiment it came from, my new experiment name, and any saved illustrations, advanced analyses, attachments and protocols, and this is where you can upload any file size or file type to give context to this experiment. So if you have completed analysis and you have a spreadsheet or a PowerPoint presentation you want to attach to this experiment so other people can see it, you can do that here with its attachments. And you can go through and upload a protocol for how it was stained or how it was collected, and then come down here and see a list of all of the FCS files. So again, not too complex of an experiment, a couple that have been stimulated, a couple unstimmed, and then the comp controls for the panel. So that's the experiment summary page. I'll now dive into the working illustration. So the first step in Cytobank is to annotate your experiment, to tell the software how the files are treated, which ones you are interested in, and then use that to go through and build figures. So we'll go back to the working illustration. It's up here under the Illustrations pull-down menu. You can also click this arrow, and that will very often bring you back to the working illustration. So here at the top of the working illustration, you can see what we call figure dimensions. We have channels that we read in from the flow cytometer. So if you name them at the cytometer, we read that name in. We also have different populations. We haven't gated yet, but this is where they'll appear. And then we also have all these other figure dimensions that we haven't turned on yet. And which ones you turn on will depend on how you've designed your experiment. In this case, we just have a couple different stimulation conditions, so I'll turn on conditions. But if you have a kinetic component to your experiment, or different doses, or different mice or patients, you turn on these other figure dimensions. Again, in this case, it's relatively simple. We just have one figure dimension we're going to use, so we'll click here to set up. So in this case, you can see a list of all of our untagged files. And we're going to type in a list of conditions. So we have unstim, IL-10, IL-6, and LPS. I'm going to add these conditions, which makes the bins show up here. And if what you type up here matches what's in the file name of the FCS files, then Cytobank will sort them out for you. So again, a little effort when you're composing the experiment. You're naming the FCS files at the cytometer, you're naming your channels at the cytometer. That pays off in Cytobank because it saves a lot of time during this annotation step. If the files are not named to match the bin names, you can still click and drag files into any that you'd like to. So no worries if you have things like sample 001, 002, you can still click and drag them to their correct bins. I'm going to leave unstim2 untagged, so you see what happens when you leave something untagged. It doesn't appear in the eventual working illustration that we're going to start building. So keep that in mind. If you have controls, you can leave them here and they won't show up in your eventual figure. So the rest of these look okay. If you'd like to import these from previous experiments, you can do that using this button. And this is a theme in Cytobank. You can import many things from past experiments, which can act as templates. So you can import lists of conditions or time points or patients. You can import gates or compensations, scales. You can import saved figures or stats export templates. So there's a lot of work that you can kind of pull from if you're doing similar experiments. So keep that in mind. So we have our conditions set up now. So we'll go back to the working illustration. And then one more thing I want to cover is the panel setup before we dive into gating. If you have a panel or channel conflicts, there'll be a little warning that pops up at the top of your page. To see those, you can click on Setup here under Channels. You can see if you haven't named your channels at the cytometer, you can do so here. You can type in and change these names. In this case, we already have, so we don't need to change them. And if you need to move compensation files, if they don't have comp or beads in the file name, they'll likely appear in panel 1. You can highlight them and choose to either move it to a compensation panel or make a new panel. So keep that in mind. We're not going to do anything here. Again, this all looks great, but if you do have panel conflicts, you can fix those in this page. All right, so now we're ready to gate. We're going to dive into scales, compensations, and then drawing some gates. And then after that, we'll go on and create some illustrations. So here now is our working illustration. We've set up our conditions, we've made sure our channels check out okay, but we need to now have some populations. This is single cell data that we're working with, so we want to focus in on the populations we care about. So you can either click here to gate, or you can click on this gating shortcut up in the shortcut window up here. Either will take you to the same place. However, before we start gating, I mentioned scales and compensations. It's very important to remember to do these first in Cytobank, as Cytobank does not save gates and then convert them if you change a scale or change a compensation. So again, make sure you set up our scales and comps first. And generally, I like to do compensations first because sometimes we need to adjust the scales after we change the compensations. So click on this comps link up here. If you compensate at the cytometer, you don't need to change any compensation in Cytobank. We use the cytometer compensation by default, and so you don't need to do this. However, if you compensate post-acquisition or you need to tweak something you did at the cytometer, this is the place to do that. So there are three kind of ways to get compensation matrices in Cytobank. One is to just make your own new matrix. By clicking on New Matrix, it'll have you select channels you'd like to use and just give you a blank matrix and let you fill in numbers yourself. It's a little old school. Some people still use it, but it's definitely not the recommended way to get a compensation matrix. Under Import, you can pull other compensation matrices into Cytobank, either from files that are uploaded as part of the experiment already, from previous Cytobank experiments, or from other software that lets you save compensation matrices as CSV files. So keep that in mind. If you want to comp in another software, you can save it as a CSV file, you can upload it into Cytobank. And then lastly, what we're going to do here in this case is the automatic compensation. So we have comp controls, so I'm going to click on automatic and highlight the channels we'd like to compensate. In this case, it's just 6 channels. It's not too difficult. We have a list of options to choose which files have our positive peaks and negative peaks. In this case, each file has its own positive and negative peak, so we're going to use independent ones for our negative controls. However, if you have one file with a negative bead for all of your positive standing controls, you can use that here. Again, if you have things that match the names of the channels, if you have comp controls that match the names of the channels, Cytobank matches them automatically. So it behooves you to do a little work on the front end, and it saves you time on the back end. From here, we'll click Calculate Compensation. And this will give us the gates it used, the matrix that it ended up with, and then an opportunity to double check to make sure that it's reasonable. So you can see down here the gates it used on our compensation control beads. You can see the matrix that it generated. And then let's take a look at an example of this compensation. So here you can see the compensation matrix name. If you want to rename it, you can do that up here. And here is a relatively well compensated spread of data. You can see it's bumping up against the axes a little bit. This is easily fixable in the scale window. So I'm happy with this compensation matrix. If you need to change anything, you can click inside of these boxes and edit these values. However, for your own data, it would be a good idea to check each channel to make sure that it's correctly compensated. So now we're going to go to scales and see if we can fix some of these events on the axes issues. So we'll click on the scales link and it pops up this little light box, and now we have the opportunity to see a list of all of our channels, a list of the channel type. We use ArcSignH. which is very, very similar to bi-exponential or hyperlog. It lets you look at linear and log scale data on the same axis. Argument is very similar to width basis or a cofactor. It tells you what area around 0 you'd like to be linearly scaled. Then you can change the mins and the maxes as well. So in this case, I'm going to go and change this to density dot, and we were looking at CD33 versus CD20. I'm going to change the compensation to the matrix that we were using. And now if I want to lower the minimum just a little bit for CD33, I could do so. We'll make it perhaps negative 400. Another channel of interest that is worth looking into is phospho-P38. So here we go. When you compensate this channel, there's a lot that are pressed up against the axis. So we're going to go and make sure that we can see all of this actually on scale. So we'll come down here to phospho-P38 and make it negative 2000 instead of negative 200. And that brings everything up on scale, and we're good to go. So again, in the interest of time, I won't do this with every channel, but it's a good idea to make sure all of your data is well scaled. A note, the algorithms will use the scale type described in the settings page, and if the scale type is set to arcsine H, it's very important to make sure that your scale argument is set correctly. If you see any kind of symmetry around 0, anything that looks like a butterfly or 2 raindrops, that could be an indication that you need to increase your scale argument so that the algorithms don't see artificially 2 populations. If you have more questions about this, again, feel free to write in at support.cytobank.org, and we'd be happy to answer. However, in this case, we have everything set correctly. We're going to go back now to our compensations and then go back to our working illustration. So now we have our comps set up correctly. We have our scales set correctly. You can change your compensation now to this new auto comp. Anytime you change a setting in Cytobank for any of the working illustration settings, it pops up this green Update Illustration button. That way it lets you change as many things as you'd like, and then you can affect those changes. So now we have our compensation set correctly. We can hop back into the gating page. And now we can actually start drawing some gates. So again, it's a good idea to make sure that your compensation is set correctly to that new comp if you've generated one. However, if you comp at the cytometer, again, that's fine. You can use the file internal compensation. So we'll just draw a handful of gates here real quick and isolate some interesting cells to use to build some figures with. So I've just drawn a scatter gate around my PBMCs, excluding some debris and some larger events. If I want to now start making a hierarchy, in Cytobank that's done with our active population. So right now I'm saying I want to see all of my events, I want to see ungated. If I switch it now to viewing scatter, which is the name of the gate I've just drawn, we only see our scatter events here in this plot. Now I can go on to change the axes, perhaps to CD20 and CD33. And now I'm going to draw a few more gates. So again, this is how you get hierarchy in your gating scheme. So we'll highlight this population, call it B cells. And this population, call them monocytes. And we'll do kind of a cleanup population here, just for the sake of making the hierarchy a little more complex. We'll call this CD33 negative, CD20 negative. Click OK. And now I'm going to make this my active population. I'll switch the axes now to CD4 versus CD3. And we'll call this CD4 positive T cells. And we'll call this one CD3 positive, CD4 negative. Okay, so now we have a handful of interesting populations. In Cytobank, when I've drawn these gates are drawn globally. So I've drawn it on the IL-10 sample. If I click over, it's also drawn on the IL-6 sample. It's also drawn on the LPS sample, as well as the unstem samples. So Keeping this in mind, if you need to alter the position of a gate for a new file, you can highlight the gate in question, come down here and say, I want to tailor my gate per file. And now, if I alter the gate for one file, it doesn't change the position for all the other files. You can tell a gate is tailored. It has a little T next to it right here. I actually don't want to move this gate up here. That's a terrible position for my T-cell gate. So I'm going to come back to an appropriately positioned gate and then turn that tailoring off and say OK. And then that fixes that. If you want to change a gate position based on its parent population, for instance, if you want to move your CD45RA gate for your CD4s as opposed to your CD8s, that's what tailoring per population means. This is a more kind of traditional way to work with gates in a hierarchy, similar to existing software out there. In this case, I don't need to do either of these. I'm pretty happy with how these gates have turned out. If I want to check just to make sure, I can either click through all of my files, or I can highlight a gate in question, come down here and click on this check gates. When the plots load, you can see how each of your files has been gated and ensure the gate is drawn correctly. As we scroll down, we can see each of these statistics, and sure enough, these gates look very reasonable, so we're happy here. However, this can be a great resource if you have 15 or 50 or 300 files to look at. It's a great way to go through and look at these gates. Now, if we want to see the actual hierarchy, we can come down here and either use the population manager. And the way to interpret the population manager is the list of gates on top, a list of populations down the side. And you can see that the scatter population is inside of the scatter gate. The B-cell population is inside of the scatter gate and the B-cell gate. And the CD4 positive T-cell population is inside of the scatter gate, that cleanup gate, and then also our CD4 positive T-cell gate. So these act like Boolean AND operators. If you need to change the position of any one of these, you can do so by either adding or removing these checkboxes in their kind of gate definition. To see a traditional hierarchy, you can click on population tree, and it gives you that much more relatable view. And then there's also the population sunburst. So this is a way to display hierarchies much more visually. It's based on circumference. Ungated is 100% of the cells, so it's 100% of the circumference of a circle. Scatter is most of that. You can see here it's about 90%. So it's about 90% the circumference of a circle. And as you move away from the center, you move kind of deeper into your hierarchy. So you can see here B cells, monocytes, they're about pretty similar in abundance. There's a lot of these 33 negative, 20 negative events. And you can see inside of this arc, deeper into this arc's hierarchy, you can see these two new populations. If you'd like to focus on just one aspect or one branch of your hierarchy, you can click on a particular arc and make that 100%. So you can navigate in and around these populations and view different files, view different colors, and also export this to PDF in case you want a record of this for a poster or a PowerPoint presentation. So once you're happy with how your gates look, you can come up here to these two buttons. So it's very important to remember that all the work you do here is automatically saved. Each action you take is automatically saved. However, it's not applied back to the original experiment. You have to click on one of these buttons to get that to happen. So if your browser closes on accident, your work won't be lost, but you do have to come back and hit apply and return before it's visible. So if you do a lot of gating, you go back to your working illustration and you see all of a sudden none of it is here, all you have to do is go back to the gating page, hit apply and return, and then those populations are made available for you. So now we're going to hop into how to make illustrations, how the working illustration works, and then we'll get into export stats and a few of the sharing things. So briefly, we've done the annotation work, we've done gating, we've got some populations to use now. Now we're going to start rearranging these to get figures. Here you can see by default we just have side scatter selected looking at our ungated population, split apart by our 4 different conditions. But that's not very interesting at all. Cytobank builds figures based on rules, and the rules are the positioning and what's selected in these figure dimensions. So I'll come up here and click on choose and turn off side scatter, and instead turn on our phosphosignaling endpoints, phosphostat3 and phospho-p38. I'll also choose some more interesting populations. I'll turn off ungated and instead select some of these endpoints, and then keep our conditions. And now when I click update, Cytobank takes what we've directed up here and builds a figure based on that. You can see channels is in the columns position, populations is in the rows position, and then everything is laid out in larger tables by different stimulation conditions. So you can see here for B cells, monocytes, CD4 T cells, you can see what their levels are in phosphostat3 and phospho-P38 for the unstim, for the IL-10 stimulated, and for IL-6 and LPS. So this is okay, but it's a pretty clunky figure. It's really kind of difficult to compare what happens across stimulations. So we can come up here and actually rearrange the positioning of these. So we're going to take conditions and move them into rows, because I'd rather see everything laid out on a large scale by cell population or by cell type, rather than by different stimulation condition. So now I'll click update. And you can see for B cells what happens with these stimulations. Or you can see with monocytes what happens with these stimulations. And it's much easier to see what's going on now when you have it arranged like this. So after an annotation step, Cytobank makes it very easy to go back through and rearrange figures and explore your data. If you want to take a different tack and display your data by a different plot type, you can do that here. You can click on heat map, for example. Now click update. And now we get a great view of a summary, essentially, of these responses of these different cell types. You can see monocytes, how they change with stimulation, how phospho-P38 goes up with LPS stimulation. And if you want to see what the actual distribution is like, you can mouse over these cells of these heat maps and see what the underlying data is to make sure you have a good comprehension of the data is bimodal or if there's outliers. It's a great way to go through and figure out kind of what's going on underneath these images. If you'd like to change any of these settings, heat maps are colored based on the numbers in these tables, and the numbers in these tables are dictated by these statistics settings here. So right now we're coloring by the median values of the x-axis channel. You can come up here, you can see the x-axis says use the panel channel values. That essentially means just select what we have up here. However, if we'd like to change what the x-axis is, we can do that up here. We can change what the statistic is. Instead of medians, we could look at means, we could look at event counts, geometric means, whatever you'd like, you can color your heat maps by. You can also, instead of heat maps, look at histograms, click update, and they'll be colored similar to a heat map, except now you can see the underlying information. So you can see the distributions, you can see where the peaks are in a nice overlaid histogram. And the histogram will overlay whatever figure dimension you have in this position. In this case, you can see it changes to overlaid. So if we wanted to save this figure, if we like this one a lot, we could come up here and click Save, and then save a copy of this working illustration. This makes these settings available to everybody that is shared on this experiment. So I'm going to come here and say histogram overlay. And now we have a saved figure. If we come up here to illustrations, we can view recent ones. You can view all saved illustrations. I have my working one and that one I just saved. As more people use this experiment, if I share it with other people, they'll have their own working illustrations and their copies of saved figures, and everything will be accessible here. To get images out of Cytobank, you can do it a couple ways. The fastest way, and the way I often use, is just to take these images, which are JPEGs, and copy and paste them into PowerPoint, again, along with the scales, if you're going to be using the coloring. If you'd like a little bit more formal way to get the images out, you can either switch into printer-friendly view. This will go through and give you a page to print and a QR code on that page with an address back to this figure. So if you ever physically have a hard copy and a piece of paper of this, you can always get back to the link, to the address where this was generated from. You could also save a PDF, or in Firefox, you can save your figure as an SVG and then open that up in newer versions of PowerPoint or in things like Adobe Illustrator or Inkscape. So that's how to get images in Cytobank. To get stats, we'll cover that next. So we've covered the working illustration. Exporting stats is next, and then we'll talk a little bit about sharing and some other things in Cytobank. So I already covered illustrations, sample tags. This is just a shortcut to any of those annotation things. We won't be talking about our algorithms today, and gating is, again, a shortcut to gating page. The actions window is where I'll talk about next. We used the view summary page. We cloned a little bit. Under import is where you can upload more files to an experiment if you'd like to. It's where you can import gates from a gating ML file or upload sample tags. Export, this is what we're going to be doing next, is exporting stats. But you can also export an experiment as an ACS file, which is essentially the whole experiment, the raw data, any advanced analyses, any saved figures, any attachments. Zip it all together in an ACS file and have that to archive. You can also export gates as gating MLs. You can download files from Cytobank onto your local computer. But we're going to be doing export stats now. So I'll click on export stats. And it brings us to this page where if we had any saved templates, we could load from them. If you're doing the same work over and over and over again, it can behoove you to save some time and save a template. But in this case, we're going to define what to export new each time. So under export options, you can change the file name. You can change how the table is oriented. For those of you working with computational collaborators, they might be interested in this. You also can change which compensation you're using. And again, just a heads up, it's a good idea to make sure that you have your compensation set correctly before you start exporting stats. But I'm happy with all of these options. And then we get to start building the table. So we're going to add a stat, for instance, medians of our monocytes in phosphostat 3 and phospho-P38. So we can add these two columns, and you can do the same for CD4, these potential CD8s. You can also do percent of population. This is basically percent in gate. If you'd like details on how we calculate this, you can click on this little I link, and it'll bring you to our support page. For those of you who haven't tried, if you go up here to Help and then Support Home, this brings you to a great resource where we have a lot of written material on basically everything in Cytobank. So you can search for a particular topic if you want to, but there's lots of links right here to getting started, the essentials, how to do gating, how to do sample tags. If you can't find anything you're looking for there, or if you have a question about your data in particular, we're happy to help. You can click on this Submit a Support Request, and essentially you can compose an email to us with a subject, a description of your issue. If you have a screenshot that you think might help, you can certainly add that in here, and it goes to a bunch of us here at Cytobank, and we're happy to answer your questions. So definitely feel free to take advantage of this resource. So if you want a percent of population, you can do that here. We also do event counts, geometric means, etc. So there's lots of different ways or stats to choose from. We also spent some time annotating, and we can include those annotations in this file. We have different conditions now. So I have a whole bunch of stats and now some conditions. You can also add file keywords. This is from the metadata in the FCS file. Many people don't use them, but they're available to you if you'd like. I'm actually going to take conditions and rearrange it, click and drag it up there, and I'm happy with this template now. To export this, I can click on this green button, and I'll get my exported stats page zipped as a file for download. So I can download it, uncompress it, and then open it. It's a CSV file. You can open it in Excel or Google Sheets, OpenOffice, whatever one you use. It's also attached back to the experiment summary page. So you can have your local copy of this, but anybody else who's interested can see this exported file and download it for their own work. So that's the stats export workflow. We're now going to hop into how to share things in Cytobank. So we talked about exporting stats. So if you've done all this work, how do you let other people see it? The sharing options are up here on this kind of quick start bar. Right now, this experiment is private. All experiments in Cytobank are only accessible to the person who uploaded them until you decide to change that. So right now, I could share with my colleague Hannah, and I could click on her name, and then she would have full access to this experiment. She could make her own gates, she could change the compensations, make new figures, download the files. That's great for a collaborative relationship, However, if you just want to show your data to other people and have them consume it, there's two things you can do. If you're on your company's Cytobank server, if you have an enterprise server, you can make it public. If you make an experiment public on premium, it goes to many, many people all around the world, but that's okay. If it's attached to a well-published journal article or something, you might want to show off your data. That's legitimate. However, if you'd rather share with a limited group of people, you can use projects. So up here, right next to the experiments page, is projects, and we're going to make a new project here. And we'll call it Basics in Cytobank. You can give it a description if you want to, and then you get to choose a sharing level. View only or illustrations. View only means the people that are part of this project can only see what you've done. They cannot make their own illustrations on your experiments. And conversely, illustrations means they can make their own illustrations on your experiments. Cloning level disabled means they cannot make their own copies of your data. Files only means they, unsurprisingly, get to make only copies of the raw data. And then full clone lets them copy all the work that you've done into their own experiment. So we'll create this project. And now we get to add people to the project and experiments to the project. So managers can change these settings. Leaders and members have the same permissions, but you can make a PI feel good now if you make them a leader. So we'll make Hannah a leader of this project. And now we can add experiments to this project. So for instance, if I wanted to add this experiment to the project, I can highlight it, add it, and now Hannah will have this level of accessibility to this experiment. Projects are a great way to organize your inbox and also enable collaboration. There are a few other things in Cytobank that I'd like to highlight. One is the API, which stands for Application Programming Interface. Essentially, it lets you send code to Cytobank and have Cytobank carry out things automatically for you. Normally, people interact with Cytobank in a browser, Firefox, Chrome, or Safari. However, if you have the API, which is just optional, it's not necessary, but if you're feeling computational or you want to learn something, you can use the API to kick off operations in Cytobank. You can also use the API to export data to an external system, like a LIMS system or a central data repository. Or you can use the API to extend Cytobank to help you run algorithms on your data that we don't offer as part of Cytobank. So you can take data from Cytobank that you've run our algorithms on, download it to your local computer, run your own code on that data, and then upload it back to Cytobank all automatically. So keep that in mind. If you'd rather just dip your toes into that kind of operation, we offer the Cytobank Bridger package, which is written in the R programming language, as opposed to the API, which supports all programming languages. Cytobank Bridger allows you to perform some advanced functionality automatically, quite simply with the command line. So it allows you to make cluster gates. If you have cluster channels from Spade or from Phenograph or from another clustering algorithm out there, you can take those and make cluster gates automatically with Bridger. You can automatically bubble Spade trees in Cytobank. And if you have a very large set of files to download, you're having connectivity issues, you can use Bridger to automatically download the whole series of them one at a time. So it's a great way to kind of bridge that gap between kind of a wide open, really flexible Cytobank API and some advanced usage. One more feature I'd like to talk about is Cytobank Drop. This is essentially the tool in Cytobank that allows you to upload spreadsheet data instead of FCS files and then run all of our tools on that data. So this allows you to look at things like single-cell RNA-seq data, segmented image files, Luminex or nanostring data, outcome data, metabolomics. These are all bulk, so instead of each dot being a single cell, each dot would be a sample, but that works just as well in things like Visney. But you can get even more creative and upload things like usage stats or marketing data, restaurant reviews, and run Visney on things like that. So again, its purpose is for biomedical data, but please feel free to tinker. It can be pretty fun to see what groups with other things from all other kinds of data. So in conclusion, Cytobank provides exceptional analysis, collaboration, and archiving tools on a secure and flexible cloud platform. If you'd like to try out Cytobank, if you haven't yet, please go to premium.cytobank.org and you can have a free 30-day trial. If you have questions as you get started or about anything in particular, we'd love to answer them. Just go to support.cytobank.org and send us an email. Or if you have questions about accounts or getting access to Cytobank, sales@cytobank.org is there to help you out. Thank you so much.